All right, lesson 10.3 is the binomial theorem. All right, so first of all, let's go ahead and start off this lesson with just some quick review. Yes, in the last lesson, if you remember, we talked about permutations and combinations. And a permutation is when the order matters or is important. Okay, and a combination is when the order doesn't matter. Okay, so in number 8, it says 8 members of a school marching band are auditioning for 3 drum major positions. In how many ways can the students be chosen to be a drum major? And you got to look, the first question you got to ask is, are we putting people in specific positions? And the answer to this one is no. We have, first of all, this is plural, so that's going to be your first clue. We're just putting them in 3 positions. We got 8 people, but we're going to put them in 3 positions. So we have 3 positions to fill. We have 8 people for the first spot, 7 people for the second spot, and 6 people for the last spot. And remember, since the order is not important in this one, this is a combination, so we've got to divide by, we have 3 numbers, 3 factorial. Okay? So if we do, oops, clear this, 8 times 7 times 6 divided by 3 factorial. We get answer of 56. Different ways, different outcomes, or different ways that we can choose the drum major. So in number 2, it says your school yearbook has an editor-in-chief and an assistant editor-in-chief. The staff of the yearbook has 15 students. In how many ways can a student be chosen for these positions? Well, we're putting these in specific positions. We're putting an editor-in-chief and an assistant editor-in-chief. So we have 2 positions to fill, the editor and the assistant editor-in-chief. We have 15 people, so the first spot we have 15 to choose from. We pick an editor, so we have 14 left. And the fundamental counting principle says you multiply, and 15 times 14 gives us 210. Okay. Number 3 is kind of a introduction to what we're actually going to be working on today. They call the binomial theorem. But remember, we're squaring this, so this is the same as if I took a plus b times a plus b. And if I FOIL it, or if I distribute the a to everything, so a times a gives me a squared, a times b gives me ab, b times a, I'm going to write it as ab plus, and b times b is b squared. So ab plus ab, I get a squared plus 2ab plus b squared. Okay, and we're going to come back to that. It'll lead us into something else. So here's basically what the binomial theorem is. And in order to do the binomial theorem, we're actually going to be expanding binomials like we did the last one. So basically our objective is to use the binomial theorem to expand a binomial that is raised to a power. And the first thing that you have to do that is use Pascal's triangle. Now Pascal uses combinations to do this, and he always starts off with doing 0, choose 0. And if you found out what the combination 0, choose 0 was, you'd find out that number is 1. And then he goes one level and he says, okay, let's do 1, choose 1, or we could do 1, choose 0. And he finds out that those are both 1. And then the next row would be combination 2, choose 1, 2, choose 0. That should have been 0 and 1. 2, choose 1, and combination 2, choose 2. And when you get those numbers, we get 1, 2, 1. Now, an easier way to get these numbers in Pascal's triangle is the first and the last one are always going to be 1. You're always going to start off with 1, and you're always going to end with 1. Okay, so that makes it a little easier. To get this number, all you have to do is take the 1 plus the 2, gives you 3. 1 plus 2 gives you 3. Here, to get this number here, we're going to take the 1 plus the 3, gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4. In the next row, 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 gives us 10. 4 plus 1 gives us 5. And then the next row, 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. and 5 plus 1 is 6. And the last row, and this actually keeps on going. 6 plus 15 is 21. 15 plus 20 is 35. 35, 21, and 7. And this does keep on going forever and ever and ever. It doesn't stop. You can keep this pattern up. We're going to stop at the 7th row. But when you're actually doing these, one thing that you ought to keep in, that you have to keep in mind is we don't start off with row 1. We actually start off with the row 0. Okay? So that makes then this one row 1. That makes this one row 2. And this is important for what we're actually going to be solving today. Row 3, row 4, row 5. This one's row 6. And lastly, row 7. And like I said, we can keep going row 8, row 9, row 10. Keeps on going forever. The other way to check this out is whatever the second number is, not the first number, because remember, the first number is always 1. So whatever the first number is, or the second number, will also tell you what row it is. Okay? So that's an easy way to remember. So let's go back to that last question we had on the first slide that we looked at, the a plus b quantity squared. So I'm going to do an example of Pascal's triangle, and then we'll actually go through the steps that you need to do. So to do Pascal's triangle, if you remember, our answer was a squared plus 2ab plus b squared. Okay? So the first thing I'm going to do is, the little 2 out here tells me what row I need to use. So remember, this was row 0, row 1, row 2. Second number has to match. And I'm going to write those numbers down. 1, 2, 1. And then the easiest way to do this is go a squared, and then you just go in descending order. So a squared, a, no a. And the next number would be, you start at the bottom where you ended up and go b squared, b, and no b. And when you're putting this thing together, you get a squared plus 2ab plus b squared. There's your answer. And if you look, that's what we actually got when we multiplied these out. So you could actually multiply these out. The problem is the binomial theorem actually makes these a lot easier by expanding them. So first of all, here's the 4 steps that you need to do. So first of all, determine the row of Pascal's triangle. And the way that you do that is whatever the binomial is being raised to, that's the row you use. So we look at the second number, make sure it matches. So we're going to do 1, 3, 1. Now, I find it easier to do these vertically. So 1, 3, 3, 1. Okay. Most other videos, if you're looking for other YouTube videos, if you look at the textbook information or the information on the intro screen, you're going to find most of them don't write it vertically like this. So the second step is you're going to raise the first term to the indicated power and list it in descending order. So it just goes x to the third. And then we go down 1. So the next one would be x squared, x to the first. This is technically x to the 0, but if you remember, x to the 0 is 0. So we don't need to, our x to the 0 is 1. So we don't even need that. So then we just look at the next one, starting with the last term, where we're down here, and you go y to the third, y squared, y, and no y. And if you're looking at your exponents should be 3. 2 plus 1 is 3, 1 plus 2 is 3, and that one's 3. And so the last thing is you just multiply and write it as a polynomial. So basically you're just going to put everything that's in the same row together. So x to the third, remember that has a coefficient of 1, 3x squared y, so plus 3x squared y. This one is plus 3xy squared, and the last one is plus y to the third. And remember that coefficient on the y is a 1. Okay? So let's go ahead and take another look at another example, but where the last term is a number. Okay? You're actually going to follow the same pattern that you did before. So the very first thing that you need to do is pick out the row. And remember, whatever the power is, so this one's a power of 3. So the second number has to match. And I pick 1, 3, 3, 1. So we're going to write those numbers down. 1, 3, 3, 1. And we're going to start with the first term. So the first term in my polynomial is the u. So I'm going to do u to the third, u squared, u, and no u. Then I'm going to come over here. 4 to the third, 4 squared, 4, and no 4. So remember, I got to do each row. So this one is easy because it's u to the third plus. Now anything that's in the row in the same box, so like 3u squared 4, we're going to multiply all those. So 3 times 4 gives me 12 u squared. Next one, remember you got to do your powers first according to order of operations. So 4 squared is 16. 16 times 3 gives me 48 u plus, and the last one is just 4 to the third, which is 64. Okay. All right, so when we're looking at the next one, so we've done one where there's been a number in the last spot, and we've done one where there's been a variable in the last spot. So this last one, or the next one we're going to take a look at is, what happens if I have a number and a variable in one of the spots? Well, the first thing is you start off exactly the same. Start off with a row. So since that is a 4, the power is a 4, then I'm going to start off with where my second number is a 4. Okay, so the same thing, 1, 4, 6, 4, 1. And then start off with the first term, just like we have, b to the fourth, b to the third, b squared, b, and no b. And then the last thing that we're going to do is the 2a, you need to raise both of those to the power. Since they're both in the same spot, when we're doing this, it's got to be 2 to the fourth, a to the fourth. 2 to the third, a to the third. 2 squared, a squared. And then 2a. Okay? And then no 2a. So remember, we've got here, this stuff goes together, this stuff goes together, this stuff goes together, and that stuff goes together. So remember, b to the fourth. Remember, we have to multiply our number, so 2 times 4 gives me 8. b to the third, a. Here, I have to follow the order of operations, so 2 squared is 4. 4 times 6 is 24. So 24, b squared, a squared. The last one, 2 to the third is 8. 8 times 4 is 32. So 32, b, a to the third, plus 2 to the fourth gives me 16. So 16, a to the fourth. Okay. Now, I understand these can get kind of complicated. So if you ever have trouble, well, hey, I don't remember how we did that one, move the video up and down and take a look at it again as you see fit. Or, hey, I didn't see how you did that step, so pause it. It's one of the great benefits of viewing this online. You can back it up and do it as many times as you need. Okay. Now, in this example, if you'll notice, all of the ones that we've had up to this point have been a minus. Have been a plus. So now when we're adding a minus, well, two things you have to remember. First of all, there's a coefficient of 1 here, and this is the same as plus a negative. So it's no different than the last one that we did, other than now you're going to be dealing with that negative 1. So first of all, yeah, we've got to pick the row out. So 1, 5, 10, 10, 5, 1. Okay. And then the next process is exactly the same. So start with x to the fifth. So we're going to do x to the fifth, x to the fourth, x to the third, x squared, x, and no x. And then when you're looking at the next one, you've got, just like we did the last example, you've got to do negative 1 to the fifth power, y to the fifth power. Negative 1 to the fourth power, y to the fourth power. Negative 1 to the third power, y to the third power. Negative 1 to the second power, y to the second power. Negative 1 to the fourth power. Oops, negative 1. Sorry, we're going the wrong way. 5, 4, 3, 2. So just negative 1 and y. So these go together. These go together. These go together. These go together. And those go together. So I get x to the fifth. Here I have negative 1 times 5, so that gives me a negative 5 x to the fourth y. Here I have negative 1 squared is positive 1. Positive 1 times 10 gives me plus 10. X to the third, y squared. And the next one, Negative 1 to the third power is negative. So negative 1 times 10 is going to give me a negative 10 x squared y to the third. Negative 1 to the fourth power is positive, so positive 5 x y to the fourth. And the last one, negative 1 to the fifth, is a negative y to the fifth. Okay, and that's what your answer looks like. Okay. Now a couple more examples. Occasionally you're going to be asked to find what the coefficient would be for x to the third in the expansion of x plus y to the 10. So I will tell you, this is not something that's hard, but some of you are going to forget to do this. So all you have to do when you're doing this is you're going to use a combination. Okay, so you're going to use a combination, just like we did on the last lesson. Okay, remember how the way we get these numbers is, so like this number right here, it's the third row, 0, 1. So it's just combination 3, choose 1. Okay, so this one would be combination fourth row, 0, 1, 2. So 4, choose 2. It's going to be 6. So this one, we're going to do 5, combination, and it's in the third spot. Okay? And that is it. So remember, when you're calculating a combination, we have 3 spots. So 5, 4, 3. And then you have to, on a combination, you don't forget you have to divide by the 3 factorial. So 5 times 4 times 3. And we find out the answer is 10. And if you look, fifth row, 0, 1, 2, 3, you get 10. Okay? Now, that was pretty easy because we could have used Pascal's triangle to find that number. But what happens if we have an expansion of 12? That means that you're going to have to add 5 more rows onto Pascal's triangle. But an easier way to do it, remember, is just use a combination. Okay? And your combination numbers, 1 comes from there. That's the first number. And just think about it. I got to have 12 in order to pick 5 out. I can't pick 12 from only 7. And then your other number comes from there. Okay? If you actually happen to have 2, because remember, this could be y to the 5th, use either one of those. Because if you notice, I have 2 15s. Well, if you use the 7, you're using one of these. If you pick the 5, put in your combination, you're getting one of those numbers. Okay? And they've all got, most of them have 2 numbers, unless you get the one in the middle. Then you won't have a choice. They both will end up with that number. It's those one where it's like x to the 4th, y to the 4th. It's usually an even row. So 1, 2, 3, 4, 5, 6, 7. So 12, 11, 10, 9, 8, 7, 6, and I got to divide by 7 factorial. Okay. So if you did that, remember, put that in the calculator, you should get an answer of 792. Okay. All right, well, that concludes the binomial theorem. So remember, when you're doing this, when you're actually expanding, just as a quick recap, you're going to pick what row it comes from, list those numbers out vertically, whatever the row is. So if we pick row 3, for example, 1, 3, 3, 1. Then start with your first term, x to the third, x squared, x, no x. And the next row to start y to the third, y squared, y, no y, on your way up. Okay, good luck.